Progress.
Hi, in this video, I'm going to discuss the medium questions in SMC 8 2023 paper. So let's go to the questions. Okay, hope you can see the questions. And once again, you see the cover page. So you have to be familiar with the scoring system, right, and the structure of the competition. So you can pause it and go over the information, right. So number 11. A prime number, okay, the definition is of a prime number is given. So what are prime numbers? Prime numbers are whole numbers with two distinct factors, right? And here it says that it's a number bigger than 1. So 1 is not a prime number because 1 has only one factor, only one, right? And all the other numbers also have 1 as a factor, but some have actually 2, some have 3. So those numbers which have only 2 distinct factors are called prime numbers, right? For example, 2, right? So 1 and the number itself, right? And the same case for 3, 5, 7. But if you take 4, right? 4, and what are the factors? So 1, 2, 4. You can see that there are 3 distinct factors, different factors, right? So from the given numbers here, there are 5. Which one is not a prime number? Now, we have to understand that checking whether a prime number is, given number is prime is actually difficult, right? But if there's a number which is not a prime, it is not that difficult to find out, right? Okay, so pause the video and do it yourself, and then come back. Okay. So from the given numbers, we need to figure out a number which has a factor other than 1 and itself, right? Now, if you do not have experience for example, so this is the answer, and I'll tell you why this is the answer, right? Because a number of this form, you should immediately know that it is not a prime, right? Not only this, even this is not a prime, right? Even this number is not a prime. How do I know that? Because I can divide this by 13. I think when you see this number, you should have this feeling that, well, maybe I can divide this by 13. So if you divide this 1313 by 13, what do you get? So get 1, 0, 1, right? So 101 is a factor, 13 is a factor, right? So C is the answer, right? So you need to think about this further, right? So for example, what do you get when you divide this by 13? So what do you get when you divide this by 13? So you need to explore, right? That's how actually you learn deeper mathematics, right? So if you just listen to what the teacher says in the classroom or someone else says, and if you do not think beyond what is said, right, what is taught, then actually you will not be able to move forward. All right. All right. We'll go to the next question. So this is actually a very famous question in the grade 5 scholarship exam. This can be done in many ways, right? Let's see. A farm has a total of 25 chickens and rabbits. Their legs add up to 86. How many chickens are there in the farm? Now, this can be done in many ways. As I said, here I'm going to do this way. So chickens, I'm going to denote by C, the number of chickens, and the number of rabbits I'm going to denote by R. So this says that C plus R is 25. and then their legs add up to 86. So if there are C number of chickens, then there are 2C number of legs, 2 times C, and then 4R, 4 times R time of rabbit legs, and these legs add up to 86. Now uh, these two equations are called, is actually an example of simultaneous linear equations, right? So if you do not know the name, you should know these simultaneous linear equations, right? So we can solve this easily this way. So I can multiply the first equation by 4, right? So I'm going to write here 4 times 1, right? So I get 4C plus 4R is equal to 100. So this is my third equation. So I'm going to label this as number 3. And then I'm going to subtract 2 from 3. So 3 minus 2. What do I get? So I get 4C minus 2C, which is 2C, and 4R minus 4 is 0, right? And then 100 minus 86. So this is 14. So the C is 14 over 2, and this is 7. So number of chickens is 7, right? So if you want to actually see how a grade 5 scholarship exam student can solve this, you should actually watch SLMC 4. We gave this type of question in SLMC 4 2023 paper. I believe that this is last question, number 30. So you can watch that video, right? If you want to see different ways of doing this, right? Without using the knowledge about solving simultaneous linear equations, okay? All right. So, here, let's go to the next question. The number 36 has the following property. 36 can be divided by its digits without a remainder. For example, 36 is divided by 6. With the number 38, it doesn't work. Yeah, 8 does not divide 38. So I don't know whether you are familiar with this notation. This is actually the division, not the long division, right? Dividing an integer by an integer, whole number by a whole number. We don't actually go into long division, right? So for example, 6 divide 36, right? So 8 does not divide 38, right? So divide means this, right? This vertical bar. You want to say that does not divide, you cut it like this, right? Okay. So how many numbers between 30 and 40 have the same property as 36? So let's see. We have 30. Well, no need to worry about that because 0 does not divide any number. So we don't have to worry about 30. So 31, yes, 1 divides 31. 32, 2 divides 32. 33, 3 divides 33. 34. So 4 does not divide 34. And 35, 5 divides 35. And 36, yes, 6 divides 36. 37, I believe that it is a prime number. 38, 8 does not divide 38. Yes, it's given in the problem, right? Yes. And 39, 9 does not divide 39. And of course, 40, no. So how many? 1, 2, 3, 4, 5. Is it 5? So 30. Yeah, 1, 2, 3, 4, 5. So there are only 5, right? So the answer is 5. And we make sure that I have not done a mistake. So the 30, 34, 37, 38, 39, no, yeah, and then 40. Yeah, that's correct, right? Okay, we'll go to the next question. So I'm going to erase this so that we can have our view is not obstructed. My erase doesn't work. Okay, now it's working. Right. Okay. Okay. Right. The following figure gives a side view of a structure made of 32 small cubes of volume 1 cubic centimeter. 1 millimeter of paint is needed to paint one face of a small cube. Right? How many milliliters of paint are needed to paint the structure, including the bottom? So we'll start with the bottom. Right, bottom. So how many faces are there to paint? So there are 16 cubes, right? 4 times 4. So we have 16 faces to paint. 16, right? Now what about the faces facing up, right? Faces facing up. Now you might want to count them, right? But if you think a little bit, you can see that that number has to be the same as the number of faces in the bottom. So again, you have 36. Now, if you're not so sure, you can check whether it's correct by painting those faces facing up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See, it's correct. Right. So now we are going to count the number of faces, right? We have, look at it from this side, right? Right. So from this side, the number of faces, right, should be same as the number of faces from this side. If there's no hollow, even the bottom has, to say that the bottom has 16 faces, we should know that there's no hollow inside the structure, right? Now, how do we make sure that there is no hollow inside the structure? Well, this is made of 32 small cubes. So at count these 32 small cubes. So let's say that there is no hollow, right? So the bottom layer, so if there's no hollow, right, there has to be 16 cubes. And the next layer on top of it, right? So that is actually 16 minus 7, right? Cubes, right? Sorry, 16 minus 6 cubes. I mean, raise it count. So this is actually 10. And the next layer, I can see that there are 6. No, 5. 5. And the top layer, just 1. So 16 plus 10 plus 5 plus 1. So that is actually 32, right? So that means there's no hollow. So then we're going to count the number of faces we see from this side. How many we see? Well, the bottom layer, we see 4 faces, right? And the next one, 3, next one, 2, see this one, 4, this one, 3, this one, 2, and this one, of course, 1. So that is, sorry, 1. So 7 this is 10, right? 10 faces. And then even from this side, 10 faces, right? Then let's count the number of faces, right? From this side, how many? So the bottom layer, so this one, it's 4. Next one is also 4. Next one is 3. And the last one is 1. So how many? 8, 11, 12. 12. So 12 faces, right? And even from this side, 12, we don't need to paint and count 12. So how many? So this is, I'm going to add in blocks, 32. And this is 20. And this is 24. So 24 plus 20 is 44. The 44 plus 32 is 76. The answer is 76. Okay? So you can see that even counting can be fun, right? You can find shortcuts, right? With reason. All right. Let's go to the next question. How many different numbers can be made by rearrange the digits in the number 1 to 1234? Count the number 1234 too, right? Now, those who are in higher grades know that this, for them, this is a very easy question, right? So this has 4 digits, right? And the answer is going to be 4 factorial, which is, they know how to do this, 4 times 3 times 2 times 1. So it's actually 24. But without that, we can count this, right? So I'm going to draw 4 boxes for the 4 digits. And then I'm going to look at the number of choices for the thousands digit, right? When we scramble the digits of this number, rearrange, right? So thousands digit box can have 4 choices, any one of 1, 2, 3, 4. But after we put 1 in that box, for the hundreds digit box we have, hundreds place box we have only 3 choices. And for the tens place we have only 2. And for the ones place we have only 1. And then when you multiply these numbers, you get this one, right? Which is 24. And this is by the multiplication principle, right? Now, I'm not going to explain this here because then it will be another lesson, right? Another session, right? So if you do not know, then you should learn about it, right? Without that, we can't do these combinatorics problems, right? Combinatorics. That's the name for these type of questions, combinatorics, right? All right, we go to the next question, which when each of the digits 3, 4, 5, and 6 is placed in a square below boxes, right? A sum of two-digit numbers is formed. What is the largest possible sum? Well, we can actually do this for, we can look at every such combination, right? Arrangement, right? And then look at the sum and then pick the largest one. But we are smarter than that, right? Because we know that the sum is going to be largest when the 10-digit places, right? The places which contribute the most to the sum, right, have the digits 5 and 6, right? Then 3 and 4 are going to be the units digits, right? Then from 5 and 6, we get 50, 60, and then from 3 and 4, we just the units, right? So what is this? This is 117, right? The answer is 117, okay? All right. We go to the next question. Now, as I say, you need to pause the video and do the problem and then come back for the discussion. Digit sum. Yeah, some of the digits of a number, right? For example, we take 19. Its digit sum is actually 10, right? Digit sum is 10. Is 1 plus 9 is equal to 10, right? So how many 2-digit numbers have the digit sum 6? So only 2 digits, right? So yeah, the 2 boxes, 1's place, 10's place, right? Now, if the digit sum is 6, right, we can't have a digit bigger than 6 in this places, ones place and tens place, right? So it can be 6 to tens place, right? Ones place 0, 60, right? So we have 60. Now don't even think about 06. It's not two digits. It's not a two-digit number. And then 51 was 15, and then 42, and then 24, and then 33. Those are the all two-digit numbers with the digit sum 6. So the answer is 6. Okay. Okay, let's go to the next question. Two corners of a square piece of a paper are folded into the middle of the square, and the following pentagon, bisected polygon is created. Yes. What are the sides? Sorry. So sides. Right. That was the question. If the areas of the pentagon and the square are consecutive whole numbers, what are consecutive whole numbers? So these are whole numbers one next to the other. You know, what is its magnitude, right? So, for example, 1 and 2 are consecutive numbers. 2 and 3 are consecutive numbers, right? And 4 and 3 are consecutive numbers, right? So, what is the area of the pentagon, right? Okay. Now, if the area of the square is x, since we don't know, x is for the unknown, right? X. What is the square? What is the if the area of the square is x? What is the area of the pentagon? So it is something less than x. How much less? So we need to subtract. So we need to fold this, right? Here, let's use a different color, right? You fold it, right? You lose how much? You lose, how much? So it's actually this triangle actually square has 8 of them, right? 8 of them, right? So it loses 1/8 of a square, right? Square. And when you actually fold the other corner, right, you again lose 1/8 of a square, right? So then what is this? Well, um, since you are actually, in high grades, I think you know how to do this thing, right? So this is just add the two fractions, 1/8, 1/8, you get 2/8x. So this is actually x minus 1/4 times x, right? Even without this calculation, you can see that when you fold it, right, it loses 1/4, right? 1/4 of the area, right? So x/4, exponents of 4. And then in square centimeters, these are square numbers, x and x minus 1/4, x are square numbers. So consider the whole numbers. Now, what are the square numbers? Square numbers are actually these are the area of these squares. It's a square number, right? So the square can have either 1, 4, 9, 16. It can't have 3, right? Because what is the sign? Let's see now. The areas of the pentagon and square are considered whole numbers. Well, yes. I mean, it can be 3, right? Yeah. Doesn't have to be a square number. It can be even 3, right? Let's see. So 1, 2, 3. Let's not recognize 3. 3, 4, 5, right? Okay, if it is 1, what is the area of the pentagon? So 1 and 1 minus 1/4. That's not a whole number, right? So no need to worry about that. If it is 2, if it is 2, so 2 minus 2/4, which is half, again, not a whole number, right? And if it is 3, 3 minus 3/4, not a whole number. 4 minus 1/4, so uh, 1/4 of 4, right? So that is actually 4 minus 1, which is 3. Now, that is actually a whole number, and 3 and 4 are consecutive numbers. So the answer is, what is the area of the pentagon in square centimeters? It is 3, right? Okay. All right, we go to the next question, the last one. Let's see. Triangle ABC is equilateral and has area 27 square centimeters. The divided lines are parallel to the sides and divide sides into 3 equal lengths. What is the area of the unshaded part of the triangle in square centimeters? So you look at this and scratch your head and you don't see anything to start with. Well, maybe you can actually draw these line segments, right? And when you do that, you can see that the triangle is composed of 9 equilateral triangles, right? Equilateral triangles. Sorry, that's not the right word. Congruent. Congruent. They're equivalent, of course, but this is the right word, congruent. They are equal in shape and size. So that means each triangle actually has area 27/9, which is 3 square centimeters. And you can see that unshaded, right, part actually consists of 3 of such triangles to the section 9, right? So that's the answer to this question. Now, let me make sure that I did not skip a question, because I remember that there was, right, we missed number 18. See, we missed number 18. Manit is traveling from A town to B town and passes by 2 indicative signs along the road. One of them has a hidden number. But I think we have actually, I have, circled the answer to number 18 in the wrong place, right? So it has to be that 6 is here, not in this one, right? All right. So what is this number? So we need to read these signs, and you can see that after a little while that B town. So if you pass, like, if you go in this direction, right? So B town is actually, it's 9 kilometers from this post, and then when you pass this post, then it is actually 2 kilometers from this post. That means this distance has to be 9 minus 2, which is 7, right? So same distance, right? Here, 2, right? 7, right? So then when you go from this direction, so let's use a different color, right? From this direction, right? So the right. So A town, right? So A town actually somewhere here, right? So then to the A town, right? From this post, right, it is 4 kilometers, right? And then from this post, it would be that distance, right, plus 7, right? So it has to be 11 from this post, right? So this hidden number has to be 11, right? So I hope you got it, right? Now, so the answer is 11, right? Okay. All right. So we have done all the questions in this medium section, right? So then I'll see you in the next video uh, in which I'll discuss the hard questions, right? Okay. Till then, take care. All right.